Hello everyone, in this video I'm going to talk about the pairwise exchange method. So after we have initial layout that came from form to chart and activity relationship chart, now we are going to find out the optimal layout that has very minimum moment cost or movement cost. So as you know that material handling costs contribute almost 70% to production cost. So investigating the layout that produce minimal cost is very recommended. Okay, now let's apply to the case. I have initial layout, so basically in the first step you have to define the initial layout. My first initial layout, you can select any kind of layout. Okay, let's say I have 4 departments and I will rearrange this layout of department based on design algorithm or pairwise algorithm. So basically you have to create 2 different metrics in here. The first metric is material flow that I put in my left side, and this metric describes the unit load they carried on. For example, department 1 travel to the department 2, they bring 10 unit load. Department 1 to department 3, they bring 15 unit load, and so on. And in my right side is the distance matrix. So distance matrix tells about how many steps in every department. Okay, for example, if we want to travel department 1 to department 2, we need 1 step, so you can put 1 to this matrix. And the initial layout will be put next each other on the screen, and they adjacent each other. To see the position of the layout, we need to travel department 1 to department 2 only 1 step. And if we want to travel department 1 to department 3, we need 2 steps, 1, 2. And then if you want to travel department 1 to department 4, we need 1, 2, 3. So we can put 3 in this matrix. And continue to estimate the distance matrix until you finish. So every department already identified. So after we already fill out the travel distance, now we are going to multiply the material flow, which is the unit load, multiply by the distance matrix. And then we can know the total cost within this layout. Okay, so we have to compute the total cost for this initial layout by multiplying the distance metric with the unit load. The numbers in both metrics. For example, 10 times to 1, 15 times to 2, 20 times to 3. So just multiply it by using a parallel line. Okay, so the total calculation should be kept as a first iteration. So in this case, I have 125. Just continue to multiply it. 10 times 1 plus 5 times 2, and the last is 5 times 1, and then we got 125. So we kept this as the first total cost within this layout. The pairwise exchange method simply states for each iteration all visible exchange in the location of department pairs are evaluated, and the pair that results in the largest reduction in the total cost is selected. Now we have so many exchange composition, we can change the position department just like this alternative. 1 will be exchanged by 2, 1 will be exchanged by 3, 1 with 4, 2 with 3, 2 with 4, and 3 with 4. So we are going to exchange this first initial layout. Okay, there are the alternative of exchanging department, and of course by changing them, we have new total cost again, and our goal is finding the smallest total cost. Now let's change department 1 to department 2. Okay, now we rearrange the former layout to this one, just changing the location of department 1 and department 2. So 1, 2, 3, 4 will be 2, 1, 3, 4. So after that, the distance metric should be updated again. Okay, so in this case, if you want to travel department 1 to department 2, we need one step. However, if you want to travel department 1 to department 3, you only need one step. So compared to the previous one, okay, if you want to travel to department 1 to department 3, you need 2 steps. Okay, so I will remind you again. If we want to know the total distance, you have to recalculate again because our new layout is different. Okay, so just adjust the new selected layout and recalculate again according to this new layout. Okay, we change it. So the total cost will be different now. Okay, by multiplying the number within the material flow and also the distance matrix. Okay, this is the new matrix, so just multiply it 10 times to 1 plus 15 times to 1, 20 times to 2 plus 10 times to 2 plus 5 times to 3, and the last is 5 times to 1. So just add up, and then we got 105, and the total cost based on this new layout is 105. Okay, now let's keep it as a new total cost for former iterations, and just repeat the same step, like exchanging the department, recalculate again the travel distance matrix and also the total cost for every new layout. For example, I want to change the location department 1 to department 3, and then we got the new total cost again. And then if you want to change department 1 to department 4 and everything, just continue, just repeat the same step, and then we got that the smallest one is can be found by the layout 3214, which is changing department 1 to department 3. We got 95. So in this case, just find out the smallest value, and then we can assume that this layout is temporarily as the best layout. We kept it as the first iterations result. Okay, and this layout 3214 is derived by the layout 1, 2, 3, 4. Okay, so this new layout is derived from the former one, this former 1, 2, 3, 4. Okay, now we have the iterations. The first iteration, we got that this layout is the best, as a temporarily is the best. We have new layout taken from exchanging the former layout, which is 1, 2, 3, 4. Now the layout is changed 3, 2, 1, 4. This layout will have the same treatment, okay, just like the former iterations. So now we change the layout, okay, this layout by using the compositions, and the composition is still the same. We change department 1 to department 2, department 1 with 3, 1 with 4, and so on. So as you can see in the screen, we still save the same compositions. Okay, now I just skip the recalculation process for every tuple matrix by changing department. I just jump to the total cost. Okay, just total cost or moment cost. Okay, so within this alternative, we got the smallest total cost. Okay, let's say we got 19, and 90 is derived by the layout 2314 by exchanging department 2 with 3. The position of department 2 and 3 will be changed, and then we got 90. So 90 will be kept as the best solution temporarily again. So we move into second iterations. We have new layout for second iteration in here, which is 2314. Now, and repeat the similar process, just like recalculating the total distance matrix and also multiplying the matrix within the unit load and also the travel distance. And within this alternative, there is no cost reductions. Okay, there is no number which is smaller than the second iterations, so we can assume that iteration ends in this stage. So the best layout, this is best of the best layout, is 2314 because there is no further reductions of total cost or moment cost. So we can say that this is the best layout among all alternatives. This layout offers effective and efficient flow and also cost. So this is the example of pairwise algorithm. Thank you for watching and have a good day.